Hi. Our next lesson will be lesson 2.5, division of radicals. The objective for this lesson will be for you to be able to simplify radicals with denominators. And we will be making use of that property nth root of x over y means nth root of x over nth root of y. And note that we should not have radicals in the denominator. So this definition, rationalizing, means removing a radical in the numerator or denominator of a fraction. Here, we would be interested to remove radicals in the denominator instead of the numerator. In higher math, your teacher would be asking you to remove the radicals in the numerator. But for now, we are going to have the denominator be free of radicals. Note that in your previous lesson, if we had 5 over 9 and a square root, we simplified this as square root of 5 over square root of 9. Then this is square root of 5 over 3. We were able to remove the radical in the denominator because the square root of 9 is a perfect square. What happens if this denominator is not a perfect square? Then we would be resulting to rationalizing the denominator. So example, here we get square root of 5 over 6, for instance. From this law, we get here the square root of 5 over square root of 6. To rationalize the denominator here means we need to multiply this expression with a factor equivalent to 1 such that the denominator becomes a perfect square. And the least multiplying factor for square root of 6 to become a perfect square is itself. So this will be times the square root of 6. Then you have to do that also on the numerator so that this one is equivalent to 1 and you are not changing the value of this expression because you are just like multiplying this expression by 1. Why do we need to do this? So that we can have the denominator be free of radicals. So multiplying that, you get the numerator to be square root of 30 and the denominator is 6 squared. From law number 1, these 2 cancels with that, so we get square root of 30 all over 6. We have simplified this number. Suppose we have this, square root of 10 over square root of 50. Instead of rationalizing this denominator, I can see that 10 and 50 can be put into one radical by using this. And I get what? 10 over 50. And here, I can simplify and I have square root of 1 over 5. And this one now will be square root of 1 over square root of 5. It remains for us to rationalize this denominator by again multiplying by a factor that makes this a perfect square. And the best candidate is itself. If you do that on the denominator, you have to do it on the numerator. And square root of 1 is 1 times square root of 5 is square root of 5. Again, square root of 5, then square root of 5 is square root of 5 squared, or that is equal to 5. You can also multiply this by square root of 5 to the third. So that 5 cubed and 5 will be 5 to the fourth. That's also perfect square. But then that's not the least multiplying factor. If you do that, you will have to be simplifying in your answer. So make sure that it will be the least multiplying factor that will make this a perfect square. Suppose we have 5 over cube root of 2. We want to get rid of the cube root of 2 in the denominator. So we need to have 2 a perfect cube. The only way 2 becomes a perfect cube is to multiply it with 2 squared. So 2 to the 1 and 2 squared will give me a 3. So the rationalizing factor therefore will be cube root of 2 squared. Doing that on the denominator, you do it also on the numerator. And we have that. And this will give you 5 cube root of 4 over the denominator is cube root of 2 cube. From law number 1, this one cancels off. And you get a 2. And then we have 5 cube root of 4. For number 4, suppose we have square root of 3x over 2y cubed. We can rewrite this radical so that it becomes like this before we rationalize, or we can rationalize within this single factor here. Okay, let me write this as a fraction following that theorem. Now we are left to rationalize the denominator, which means we would want the denominator to be a perfect square because the index here is 2. So what would make the factor 2 a perfect square? So the rationalizing factor here for 2 here will be 2 here, and then y to the 4th will be y to the 1. And I will multiply the numerator with the same factor. This gives us square root of 3x times 2y is 6xy, and the denominator gives us 2 square y to the 4th. The denominator now is a perfect square, so we can extract the roots and we arrive at 2y squared. And rewriting the numerator, we get square root of 6xy. This is the simplified form of this number. Okay, for number 5, suppose we have here 0.9 x cubed y to the 4th. This radical is not in its simplest form because of the presence of a decimal. 0.9 here is not a perfect square like what we had before because the number of decimal places is only 1. Had it been a 0.09, there would have not been a problem because the square root of 0.09 is equal to 0.3. In this case, we need to rewrite 0.9 as a fraction. That will be 9 over 10. And the numerator has x cubed y to the 4th. Again, I can separate the numerator and the denominator. It leaves me with the denominator square root of 10 to be rationalized. So what will make this a perfect square? It will be itself square root of 10. In our numerator, you need to multiply that same factor, square root of 10, so that this will be equal to 1 and it will not change the value of this expression. Multiplying this, I notice that 9 is already a perfect square, so I don't need to multiply 9 and 10. Instead, I can say this is a perfect square. 9 x cubed can be split into x squared and x, and y to the fourth here is already perfect square, and then 10 is not, so we write that. And my denominator has square root of 10 squared. Simplifying this, we get square root of 9 will be 3, square root of x squared is x, square root of y to the fourth is y squared. What is left in the numerator will be 10x. And on my denominator, that will be equal to 10. So the simplified form of this is 3xy squared times square root of 10x over 10. Number 6. Suppose we have this radical. Notice that the denominator has a radical expression which is only a monomial. We need to get rid of square root of x minus 2 in the denominator by multiplying it with a factor that makes it a perfect square. This one is square root of x minus 2, so we need another one like that, square root of x minus 2, to make this a perfect square. And multiplying that same factor on the numerator, we have that. Then we multiply the numerator, and the denominator will now give you x minus 2 squared. The denominator now is a perfect square, so we can cancel this, and we have x minus 2, leaving the numerator with 5 times square root of x minus 2. For the last, in this lesson, we get this one here, square root of x minus 2. If you notice, number 6 has a monomial denominator, while number 7 has a binomial denominator. We can only get rid of this radical in the denominator by thinking of a factor that you can multiply to square root of x minus 2, which leaves it free of the radical. We call the product of the sum and the difference of two terms. This will be the only combination of two binomials that will not give you a middle term. So we strive to multiply this denominator by a binomial that will eliminate the middle term. And the only multiplying factor there will be the conjugate of this binomial, which is square root of x plus 2 and then square root of x plus 2. Multiplying the numerators, we get 5 times square root of x plus 2, and the denominator will give me a product of the sum and the difference of two terms, which will not give me a middle term. Instead, it just gives me the product of the first terms and then the product of the second terms. Simplifying this, we get 5 square root of x plus 10 over x minus 4. Suppose we have square root of 3 minus square root of 5 over square root of 3 plus square root of 5. Both numerator and denominator contain radicals, but as we said, we want to rationalize the denominator instead of rationalizing the numerator. So I will be concerned with the rationalizing factor of the denominator. This is again a binomial, so I need the conjugate of that binomial. The conjugate of this binomial will be exactly the same numbers here except for the sign. So this is plus and that's a minus. And you also have to multiply the numerator with that same expression. So we have now a binomial times a binomial and binomial times a binomial. This problem gives us a square of a binomial on the numerator. And then on the denominator, is the product of the sum and the difference of two terms. Which means we don't have any middle term, and our answer will just be the product of the first terms, square root of 3 squared, and then the product of the second terms. Simplifying this, I need again to recall how to square a binomial. To square a binomial, square the first term, square the second term. This will always be positive. And then, 2 times the product of the first and the second. So we get minus 2 times square root of 3 times square root of 5. All over. We can now simplify this. So we have 3 and this is a minus 5. Adding this, 3 plus 5 is 8. Minus 2 square root of 15 all over negative 2. Here, we cannot have 8 minus 2 square root of 15 combined with a single term because these are not similar radicals. The radical here is square root of 15, the radical here is square root of 1. So we can just retain it that way, but we can actually factor out 2 here and 2 here so that it cancels with 2 here. What I mean is, I can factor out 2 and I get 4 minus square root of 15 all over a negative 2, and this 2 and negative 2 will cancel off. The negative can be brought up and I will get here negative 4. Negative and negative will be plus square root of 15. So this will be the simplified form of square root of 3 minus square root of 5 all over square root of 3 plus square root of 5. Okay, I'll discuss one more. Let me have this last number here, square root of xy over cube root of x squared y. Okay, square root of xy over cube root of x squared y. Here we have index 2 and index 3. So therefore, we can make this into same index, or we can rationalize this one now by considering the index of the denominator. What if I want to have the same index? That would mean I will get the LCM of 3 and 2 for me to have that as my common index. LCM of 3 and 2 will be a 6. Okay? And then this numerator here will be there. This denominator here will be there. But the correcting exponent should be put there. So here, 6 divided by 2 is 3. 6 divided by 3 is 2. Okay? Simplifying this, okay, power of product will give me x cubed, y cubed, and the denominator will give me what? X4, y squared. Here, we can cancel this if you want. We can cancel that. Before we rationalize, I can have this actually x cubed and x4 division power of a quotient will give me 1 over x, and this will give me y on the numerator. In other words, I can now write this as 6th root of y over 6th root of x. We now rationalize the denominator. We need this to be perfect 6, so I will multiply this by x to the 5th and do that same thing on the numerator. Multiplying these two will give me 6yx to the 5th all over. This one and this will give me x to the 6, and there's a 6th root, and that will just be x. So that's your answer. For your assignment, just look at the Edmodo group for the division of radicals. I will give your assignment through Edmodo. Thank you.